What's going on, Alex Bros? It's Mr. C here, and in this video, just want to take you through another example of finding the domain of a combined function. In this example, we have f of x as 2x plus 5, g of x is 3x minus 6, and first thing we want to do is figure out what the combined function f over g of x looks like. Second thing will be to find its domain. So let's start with part 1. F over g of x, you may recall, can be rewritten as f of x on top of g of x. All you'll have to do is just replace each of the function notations with the expressions are equal to. So for instance, f of x is equal to 2x plus 5, and g of x is equal to 3x minus 6. Now I'm noticing that the denominator has a GCF of 3, so I'll factor that out. So 3 quantity x minus 2, whereas 2x plus 5 doesn't have anything to factor out other than 1, which we'll forego. So there's nothing more to do here. You don't have to go through with synthetic or long division. We'll just leave it as is, and that is what the combined function f over g of x looks like. So now it's on to part 2, where we find the corresponding domain. So I'm going to draft up a number line to represent the domain for the function f. So I'll denote it as capital D sub f. Keep in mind the original function for f is 2x plus 5. There's no division by 0 possible in that expression, nor is there any need to worry about negatives inside of even radicals because it does not have a radical at all. Therefore, the domain of the original function f is going to be all real numbers. Let's draft up a number line for the function g, denote it capital D sub g. And the expression for g of x is 3x minus 6. And much like the function f of x, there's no division by 0 possible, nor are there any opportunities to get a negative inside of an even radical because it does not have any radicals. Therefore, the domain of the function g of x is also all real numbers. That brings us to our third and final number line, the domain of the combined function f over g. So, as noted in a previous video, the domain of a combined function is the intersection of the domains of the original functions. You'll notice that the intersection of the original functions would yield all real numbers. But all real numbers is not actually the domain for a combined function. If you notice how we constructed the combined function, in our denominator we got the expression 3 quantity x minus 2. So by design, or how we wanted to create this function, which was via division, it forced us to put the variable x in the denominator. Now, of course, that spells trouble because it raises an opportunity to divide by 0. And if you look at our combined function, there is a particular value of x that would create division by 0 based on this factor x minus 2. So even though the intersection of d sub f and d sub g would be all real numbers, we got to keep in mind that the function we created has a variable x in the denominator. So this is what it means by you must also exclude those additional values of x that either create division by 0 or negatives inside of even radicals. So here, just by construction, we have one of those additional values of x to exclude, and that would be 2. So we have to be careful about that. Our official domain is not all real numbers because just by its construction, we have to exclude 2. So on this number line, I'll put a tick mark for 2. And since that's the only additional x value to exclude here, or only x value to exclude overall, everything else can be used as part of the domain for the combined function. And here's the interval notation for it. Parentheses negative infinity, comma 2, parentheses, union, parentheses 2, comma infinity. All right, that's it for this video. Let me know if you have any questions. Otherwise, thanks for watching.